All right, we're going to look at exponential properties and log properties that are created by examples that we looked at in the conversion rule. Base b to the power of 0 is equal to 1. By conversion rule, log base b of 1 is equal to 0. Remember, we say whatever's with the base goes to the other side. 1 comes with the base in log form. Here, base b to the power of 1 equals b is log base b of b to 1. So anytime these two are the same, it's like they cancel each other out and we get a 1. Base b to log base b of m is m. Anytime you put a log as the exponent on the same base as your log base, these two cancel out and you're left with m. And vice versa, log base b of base b. Remember how we said these cancel out? Well, there's an exponent of 1 on that b, and that's your answer. So whatever power is here, that's going to be our answer. Next, we have our product rule. Base b to the power of m times base b to the power of n. You multiply like bases, you add the exponents. Well, there has to be a property in logs that do that. Log base b of capital M times capital N can be replaced with log base b of capital M plus log base b of capital N. Remember, the logarithm is the answer to an exponent. So this is an exponent, this is an exponent, and they're being added together. So to show you how that works, let me get my iPad out here, and I'll do the product rule so you can see how that works. Let me make this bigger here. Come on. Okay, so that's my exponential property for the product rule. All right, so what I'm going to do is I'm going to say b to the little m is equal to capital M. B to the little n power is equal to capital M. Now, I do the conversion rule. All right, here we go. Log base b of capital M is equal to little m. That's the conversion rule. Conversion rule over here, log base b of capital N is equal to little n. So now if I grab my rule right here and I start to change that, we are going to replace some of that information there. We're going to take this right here and substitute it there. We're going to take this and substitute it right there. So that means capital M times capital N equals, log base, crud, I keep jumping ahead of myself here, I apologize, b to the m plus n. Now we're going to take this statement and do the conversion rule similar to what we did up above here. So log base b, m plus n is going to go on the other side by itself, and we'll have that capital M times capital N in our argument. So again, that's conversion rule. Well, I'm going to do another substitution here. I'm going to take this right here, and I'm going to take it down and replace little m with log base b of capital M. I'm going to take this and replace little n with log base b of capital N, and then you have your property of the product rule. Okay. All right. Save that. I'm going to bring that back in just a second. Next, we have the quotient rule. When you add b to the m power divided by b to the n, you subtract your exponents. Well, we're going to have the same thing in logs. If I'm dividing in the argument of the log, I can write it as two separate logs where I'm subtracting. Again, these are exponents. Your power to a power rule, you multiply the exponents. That's log base b of capital M to the power of n. you're going to take that exponent n, multiply it to the front of the log. So this is exponent n. Log base b of capital M represents little m, like I showed you on the iPad. So this is where I'm multiplying my two exponents. Now, again, real quick, one of these properties I want to rewrite. You might want to add this, and that's the quotient rule. All right, we're going to change it log base b, and I'm going to add more capital letters. I'm going to say A times B on the top, C times D on the bottom. They never show you the rule written this way. And what this will be equal to is, since I have 4 factors in my argument, I have to have 4 logs. So the rule of thumb is who's ever in the numerator are positive logs. Log base b of capital A plus log base b of capital B. And who's ever in the denominator, that's division, that's your quotient rule, we have to subtract these. So minus log base b of C minus log base b of capital D. So the rule is whatever factors on the top, they are positive logs. And who's ever on the bottom, they are minus logs when you separate that. So one of the things I don't like about most textbooks is that they only put 2 arguments in here, 2 factors. So the more you have in the bottom, they're all minus logs. All right, so what we want to do is use these properties to simplify these. So the directions will say no calculator allowed. We'll be able to work with this. So first you have log base 2 of 2 to the cube root 11. Well, light bulbs should be going off. Log base b of the same base b should just be the exponent that's on the base on the inside. So those log base 2 and base 2 are going to cancel each other out, and I'm left with the cube root of 11. Log base 2 of 48 minus log base 2 of 3. Notice that the base numbers are the same, but check out that minus sign. That's your quotient rule. That's where we're going to rewrite this as 1 log, and we're going to divide the 48 by 3, and that turns into a 16. And then 16 breaks down to 4 2's being multiplied together, which we can then change the 16 to 2 to the 4th, and now we have the same property we want to use from the previous problem. Cancel log base 2 and base 2, and we get 4 for an answer. Here, log base 6's are the same, but now it's a plus sign, so this is the product rule. This is where we're going to write it as 1 log base 6, multiply the 2 argument numbers together. 9 times 4 is 36. Well, we know that 36 is 6 squared. Log base 6 of base 6, 2. Cancel out your base 6's. The answer is 2. Now, another very popular problem that you will be given is they'll give you log base b of 2 is equal to a decimal number. Log base b of 3 is equal to this decimal number. Log base b of 5 is equal to this decimal number, and they want you to use the property of logs to evaluate the expression. So what we want to do is whatever you see in the argument, you want to break it to factors of 2, 3, and 5. So this is where, again, we'll probably bring back that factoring tree, if you will. My 12, I want to break that down. Let's go 3 and 4. 4 is 2 times 2. So this can be rewritten as log base b of 2 times 2 times 3. That's the product rule. So I can rewrite this as 3 individual logs, log base b of 2 plus log base b of the second 2 plus log base b of 3. Now what's beneficial for this is I now know what log base b of 2 is. That's this decimal. And I'm going to take this decimal, plug it in for those 2 logs, and log base b of 3 is this decimal. So I'm going to substitute those in, add them all up, 2.4848. Next example, log base b of 2.7. You are never allowed to have a decimal in this argument. So we want to change this to a fraction. The 7 is in the tenths place. So drop the decimal point and write that 27 over 10. And now we're going to break those numbers down. 27 is 3 3's being multiplied together. 10 is 5 times 2. Those are the factors I'm looking for. Now, one thing I'm going to do here is I'm not going to write it as 3 times 3 times 3 on the top and 5 times 2 on the bottom, because that's 5 factors and I don't want to write out 5 logs. So I'm going to shortcut this, and I could have done this over here as well. I'm going to write this as 3 to the third on top and 2 times 5 on the bottom, which means now I only need to write 3 logs. So remember what the quotient rule said. Whoever on the top is a positive log or a plus log. Whoever factors are on the bottom is a minus log. So log base b of 3 to the third power minus log base b of 2 minus log base b of 5. That's your quotient rule. Then your power rule says, hey, look, check out that exponent of 3 there on your base. 3 on the inside. Move that 3 out to the front of the log, and we're going to multiply it. Now, I always put a dot there, just to indicate my multiplication, to kind of separate these two. Now we'll put in the decimal, 1.0986 for the 3, 0.6931 for the 2, and 1.6094 for log base b of 5. Go to our calculator and crunch this all out. We get 0.993. If we had log base b of 30b, don't panic that there's a b there. That's actually a good thing. Just break down your 30. 3 times 10, 5 times 6, whatever you want. Just get to the 2, the 3, the 5, and the b. These are all being multiplied together. Each factor gets its own separate log. Log base b of 2 plus log base b of 3 plus log base b of 5 plus log base b of b. Decimal representation, 0.6931, 1.0986, 1.6094, and log base b of b, that's a property. That's just a 1. Add them all together, 4.4011 is your answer. All right, this one is kind of a trick question. Log base b of the square root of 6. First things first is we don't want the square root symbol. Root of 2, power of 1, rewrite it with a fractional exponent, and then we'll use the power rule like we did with the exponent 3 here. Move it out to the front, being multiplied to your log. Now break down your 6 to 2 times 3. Now this is where you have to be very careful. We're going to change this to log base b of 2 plus log base b of 3, but we have to put it in a set of parentheses or brackets because the answer needs to be multiplied by a half. So we bring in our decimals, 0.6931, 1.0986. We're going to add them together first, and then divide by 2 or multiply by a half to get 0.89585. Next, the directions will say expand the expression as the sum and or difference of single logs. So I see 1, 2, 3 factors. Well, just like you saw here, 1, 2, 3, 4 factors, 4 individual logs. Okay. 3 individual log base 2's. So time for the product rule first. Log base 2 of 8 plus log base 2 of x squared plus log base 2 of y. This one, nothing else I can simplify. Here, the power of 2 can move out to the front. Then the 8, wait a minute, I can break that down to 2 to the third power. So that's that property, log base 2 of this base 2. They cancel each other out, and you're left with 3 plus 2 times log base 2 of x plus log base 2 of y. Now, again, you don't have to keep writing this over and over and over again. You can simplify each one, then write it one final answer. Next example, log base 3 of 4 times the square root of y, all over 9 times x plus 1 to the third power. There are 4 factors here. One is the 4, the second one's the square root of y, third one is the 9, and the binomial is the 4th. So you need 4 logs. Just like we said back here, remember, tops are added, bottoms are subtracted. So log base 3 of 4 plus log base 3 of the square root of y minus, now we're on the bottom, log base 3 of 9 minus log base 3 of x plus 1 to the third power. So again, notice your bottom factors are minus logs from the bottom, top factors are plus logs. Now we'll simplify each one. All right, power rule. That 3, we're going to move that to the front. The square root of y, change that to y to the 1/2 and move the half out to the front. Then we've got one more thing we can do. 9 can be changed up to be 3 squared, so you can cancel log base 3 of 3, and that just becomes a 2. No reason to break down 4 to 2 squared, because base 2 doesn't match base 3, so don't break it down. That's as far as we're going to go. Now, we have to do this in reverse. So imagine this is what you're given, and you have to simplify it as 1 log. Here's what you're given. You have to simplify it to 1 log. So the important thing that you're going to notice is that you're going to have some of these terms, like the 3, like this minus 2, that does not have a log being multiplied to it. So you're going to have to remember, oh yeah, that's right, we canceled out the base with the base on the inside. So here's my first example. Again, product, quotient, and power rules to condense. There's 1, 2, 3, 4 terms. I need 4 logs. 1, 2, 3. That 2 is missing a log. So what we're going to do is remember, okay, log base 5 and a 5 must have canceled out somewhere. So I'm going to put in that log base 5 of 5, and then this 2 was the exponent on my 5. There it is. Now, the next thing I'm going to do is I'm going to take this 4, do the power rule in reverse, take the 4, put it back as the exponent on x. Take this 3, put it back as an exponent on y. Take this 1/2, put it back as an exponent on the 11. So I put all those coefficients back as powers. Now, plus logs, these factors go on the top. Minus logs, these factors on the bottom. So 25 and y cubed will be on the bottom. X to the 4th, and well, we could call that the square root of y. You could also leave it as 11 to the 1/2 power. Those will go on the top. All right, so it's optional to change it back. Usually they want you to convert it back into a radical. So like I said, positive log, those 2 factors on the top. Minus log, those 2 factors are on the bottom. No pluses, no minuses on the inside, just all multiplication. Okay, again, plus logs top, minus logs on the bottom. Next, you have log base 3 of x cubed minus 1 minus log base 3 of x squared minus 1. Top, bottom. Log base 3 of x cubed minus 1 over x squared minus 1. Wait a minute, that seemed a little too easy. I must be missing. Wait a minute. I am missing something. This is a difference of perfect squares. This is perfect cubes on the top. So I need to factor the inside. All right, now I can see. Here's my binomial times a trinomial with x minus 1 binomial in front. Soap your signs, same, opposite, always plus. Difference of perfect squares, your x minus 1s will get to cancel. And then this leftover is my final answer. And that wraps up 12.4.